Welcome to another video by AskMath.com. Let's read the directions of this problem. So the directions say, find the solution to the system. Given 2x equals 4y plus 6 and negative 6x equals y minus 31. So let's remind ourselves what the directions are asking for. A system just means two or more equations, and so we have two equations. That's called a system. And the solution means that it's values for x and y that would work if you plug them into the first one, and by work I mean if I plug a number in for x and a number in for y, that the left side of the equal sign will equal the right side of the equal sign. And then you have to be able to take those same two values that you use for x and y in the first equation and use them in the second equation and get the same result, that the left side of the equal sign equals the right side of the equal sign. So to do that, you could use one of three different methods. One method is graphing. Remember that any equation with an x and a y, or any two variables, where there's only addition, subtraction, multiplication, and division happening, no exponents, for example, that type of equation will produce on a graph a straight line if you were to graph it. And we have two equations like that, so that's going to make two straight lines. And two straight lines will cross at some point much of the time. Now there are two exceptions to that. One is if you had two lines which are parallel. Those will never cross each other. And so there is no solution to that system. The other is that if you had one line and then you had another line right on top of it, and those cross everywhere, so not just one point, but infinite points. So our job is to find the solution to the system, so we're assuming that there is just one solution, the solution. And that means that we have to find two numbers, an x and a y coordinate. So we're not actually going to graph to find the numbers, because graphing is not very precise. You could make mistakes with your ruler. You might not have a very sharp pencil. If there's decimals or fractions, that's also a tricky thing to be able to draw. Also, another reason to not graph is that typically the use cases for math are used by computers, and computers do a lot of calculation for you, but you have to be able to feed them the right formulas, the right math equations for them to do what they need to do. And so we're practicing here to do math that would be useful by computers, and computers don't use graphing to solve problems typically. Okay, so we're not going to graph, but we're going to use either substitution or combination. Now, substitution works best when your equal signs are lined up and you, in either equation, when you have a variable all by itself on one side of the equal sign. So we don't have that situation here. We have a y minus 31 on one side, and we have a negative 6x, but there's not just a y or just an x on one side. And same thing with the other equation. There's no variables all by themselves on one side. So substitution isn't the best method. Combination, on the other hand, works best when the equal signs are lined up and you realize that your x terms and your y terms and your non-variable expressions are lined up with each other as they are here. So our goal in combination is to add together the like terms, like 2x and negative 6x. But our goal isn't just to add them together. Our goal is to get rid of either the x's or the y's. And by get rid of, I mean make them turn into 0. And the reason that we want to do that is that you can't solve an equation that has two variables in it. You can only solve equations that have one variable in it. So our goal is to be able to add them together and get 0 when you add the x's or 0 when you add the y's. Now, if I add 2x and negative 6x, I don't get 0. Same thing with 4y and positive y. I don't get 0 if I add those. So I need to make some sort of modification. And I can either do that to the first equation or to the second equation. To the first equation, I would need 3 times as many 2x's. If I did 3 times 2x, I would have 6x, and that would make, when you combine with negative 6x, would make 0. Or I could change the second equation. I would need 4 y's to make it similar to this one, and not only 4, I would need to have it be a negative 4y so that it's the opposite of positive 4y, so that if you added those, it would make 0. Now, I tend to like positive numbers. And so instead of trying to turn a y into a negative 4y, I'm just going to stick with this first one. I'm going to turn the 2x into a positive 6x. So to do that, I'm just going to rewrite 2x equals 4y plus 6. And I'm going to put each side in parentheses, because what I need to do is multiply each side of the equation by 3. And it's 3 because 3 times 2 makes 6, which is going to add to this negative 6x to make 0. So 3 times positive 2 makes positive 6 times x equals 3. Now I'm distributing, which just means multiplying by each expression inside the parentheses. A positive 3 times a positive 4 makes positive 12 times y, and a positive 3 times a positive 6 makes positive 18. Okay, so now I'm going to rewrite my second equation below this first equation that I just changed to become this. And so now, just like you used to do old school math problems like, 5 plus 6 equals 11, I'm going to do the same thing here, just to visually represent what we're doing. This is like a big equal sign. Positive 6x, remember, if you don't see a sign, it's a plus. And a negative 6x, that makes 0. And that was the reason that we did this work up here, is so that we would get a 0 when we added the x's together. Now, a positive 12y and a positive 1, remember, if you don't see a number, it's a 1, positive 1 specifically, would make a positive 13y. And a positive 18 and a negative 31 is a negative 13. Okay, so now I don't have any x's left in this new result that I have. I have a new equation, but there's no x's, and that was our goal, because now I can solve. And to solve, I use PEMDAS, whoops, that's a D, which is the order of operations backwards. Okay, and so I ask the question, what's happening to the variable? In this case, y. What's happening to y? Is it being subtracted by something? Yes, it is. Negative 13 right there. So I'm going to undo subtraction by doing addition. I'm going to add 13. Whatever I do to one side of the equal sign, I have to do to the other. So the result is that this makes 0, and I'm left with 13y equals 13. So I've undone subtraction. Is y being added by anything? Nope. Is it being divided? Nope. Is it being multiplied? Yes, by 13. So I'm going to use the inverse of multiply, which is divide each side by 13. Because 13 divided by 13 makes 1, and that's my goal here. And it just so happens that on the other side, it also makes 1. The reason that I chose 13 was because of this 13 times the y, and that makes just y. And then it just so happens that the other side also turned into 1. So I do know what my y value is, it's 1, but I've been asked to find the solution, which means this, which is an x and a y. So far, I only know that part, it's a 1. But now I can take that 1 and I can substitute it into either equation that I'd like to find out what x is. So I'm just going to go ahead, again, because this doesn't have any negative signs, I prefer working with that one. I'm going to take 2x equals 4y plus 6, and I'm going to use substitution where the y was. I'm just going to plug in this 1 where the y was. And again, we have a situation where we used to have two variables, but now we just have one, which means that we can simplify and then solve this equation and find out what x is. So I'm just going to do a little bit of mental math here. We're going to evaluate this, and to evaluate, remember, you use PEMDAS, which is the order of operations, and when you're simplifying, you use PEMDAS forwards. So the first thing to do, there are parentheses, but there's nothing happening inside the parentheses. There's no exponents. There's multiplication. 4 times 1 is 4, then plus 6. So 4 plus 6 makes 10. So we've done multiplication, then we've done addition. Okay, so now we can solve this equation, and when you solve, you use PEMDAS backwards. Now, there's only one thing happening to x, so what's happening to x is it's being multiplied by 2. We just undo that using the inverse of multiply, which is divide both sides by the 2. 2 divided by 2 is 1, and 1x is just x. 10 divided by 2 makes 5. That is the other number. Now, anytime that you do have the solution in math, the great thing is that you can check just to make sure that you haven't made a mistake somewhere by taking those numbers and plugging them both into one or even both is best equations. So for example, let's take the second equation and just see, we haven't used that one very much. -6 times whatever x is equals whatever y is minus 31. We're just going to plug these in the right spots. The 5 was the x, so that goes in the first spot. And the 1 was the y, and that goes in the second spot. And we're just going to evaluate and make sure that this side does in fact equal that side. And -6 times 5 makes, negative times positive makes a -30. And 1 minus 31 makes -30. And that's true. And that means that our answer is correct. All right, that is the end of this problem. Thanks for watching another video from AskMath.com, where you can find more free math problems and for algebra and as well as other math subjects. Thanks for watching.